Study of different control methods of active power filter for harmonic reduction. Ankita Pol, SS Karvekar Department of Electrical Engineering, Shivaji University, Walchand College of Engineering, Sangli, India. Abstract: a theoretical study of various control strategies to extract reference current for active power filter, APF, is given in this paper. This paper presents various type of approaches, methods, and techniques in detail. The study also helps to choose the correct control solutions in power circuit design for APF applications. Keywords: harmonic reduction, shunt active power filter, reference current, fundamental current, Fourier transform, PQ theory, wavelet transform. Introduction. Almost 19 years ago, loads used by industry and customers were linear and passive. Therefore the impact of nonlinear loads on the power system has been less significant. Recently, the development of semiconductor devices has become more advantageous. In addition, various power electronic devices and electronic control tools are used to increase the efficiency of the non-conventional energy sources. Even though, the benefits of using the aforementioned devices are certainly good, but there are some demerits of excessive usage of electronic power devices. Because of the power electronic devices, harmonics is a big problem in control systems. Harmonics get entered into power system via a point of common coupling. These harmonics result in further losses, overheating, and overloading too. As a result, problems of power quality are increasing more and more. It also causes transient disturbances and reduces efficiency. The use of the above-mentioned electronic devices is responsible for harmonic disturbances as well as reactive power disturbances. Harmonics and reactive power is the main reason various problems including transformer overheating, feeder voltage distortion, excess amount of neutral current, malfunction of sensitive equipment, poor power factor and damage to electronic devices too. A lot of conventional solutions to these problems have been introduced. A passive power filters and capacitors are the simplest traditional methods to lower the harmonics and increase the power factor. But the system becomes bulky because of condensers and inductors, and it also causes resonance, which makes the system more unstable. Later, static VAR compensators with several power factor correction configurations are added. But some SVC configurations have very long response times, so they are not suitable for fast fluctuating loads as well as harmonics of lower order. Several methods of harmonic reduction are developed using the power electronics technique to solve harmonic problems. Two different control strategies. The load current equation in 12 should be periodic with period t/2. So, source current will set a new value according to load current over a half period of cycle. If even harmonics are present, the load current, full cycle integration is required. Source current is estimated with the help of product of low-pass filter output and a sine function. Under distorted voltage, along with fundamental component load current, harmonic component also supplies to average load power. Hence during distorted supply, alternative methods should be used to produce the reference source current. Bpq Transformation. Akagi have presented the theory of the instantaneous reactive power for three-phase system. It is also called as PQ theory 7-8. This theory consists of an algebraic transformation of the three-phase quantities, ABC coordinates, to the two-phase quantities, ASS0 coordinates. The PQ theory implements the Clark transformation that projects three-phase quantities into the stationary reference frame with the help of real matrix. 1. The Clark transformation. The Clark transformation transforms the three-phase instantaneous voltages IEVAVB. One advantage to use the ASS0 transformation is that it helps to segregate zero sequence components from the three-phase ABC quantities. The A and SS axis contains positive sequence and negative sequence components respectively. For balanced three-phase voltage system, the Clark transformation and its inverse is written as follows respectively. The matrices in 15 and 16 are axis transformation of three-phase ABC coordinates to ASS0 frame as given in Fig. 3. ASS0 axis is a static frame. The A, B and C axes are spatially separated by 120. Implementation of PQ theory to shunt active power filter. See Fourier transform method. It is easy and basic algorithm which is based on Fourier transform technique. This technique produces the reference current even under the distorted supply 10-11. This method also gives a better transient response to load current. If load current contains odd harmonics, then it gives better transient response for half cycle, and if load current carries even harmonics, then it gives good transient response for one cycle. Let us assume the supply voltage is rigid because of the source inductance and capacitance. As shown in Figure 5, the source side supplies a nonlinear load. Nonlinear load consists of a bridge rectifier with load, R, RL, etc. An active power filter is connected to the PCC via an inductor. The filter is used as nothing but a voltage source inverter, VSI, which supplies the harmonics and reactive quantities. In general, source voltage and load current can be written as follows, which is given by equation. D wavelet transform. A wavelet transform, WT, method 13-18 is used to extract fundamental component of frequency from three-phase unbalanced and non-sinusoidal load current. Multi-resolution analysis, MRA, 15 method is used to extract fundamental component of frequency is shown in Figure 6. The constructed controller have good frequency bandwidth selection. The controller tuning parameters are used as inputs to time frequency signals. The extraction using FFT gives incorrect outputs if the signals are distorted. One of the disadvantage of Fourier transform is that points observed in an observation window should be proportional to the numbers of samples per time. If the points in the observation window are not in proportion with number of sample per period, it leads to inaccuracy in the extraction. The wavelet transform method helps to minimize the above demerit. Wavelet analysis is a new method to applied mathematics 18. The voltage and current quantities are transferred to the time and frequency axis using the complex wavelet with the help of scaling and translation factors 19. 3. Conclusion. 1. This paper gives variety of compensation methods for three-phase active power filter. The multiplication of sine function is very simple and easy method among all. Voltage-related information is not required in this method for calculation. If load current contains odd harmonics, then algorithm provides good response time for half period of cycle, and if load current contains even harmonics, then it gives good response time for one cycle. But both algorithms give unsatisfactory performance for deformed supply. 2. The PQ theory is a fast method, but it also unable to regenerate sinusoidal source current under distorted source voltage. 3. The Fourier transform technique and wavelet transform are good one among all other methods.